So good morning, or good afternoon, wherever you're watching this video. And today we're going to look at the atomic structure of an atom, and we're going to look at all the pieces that make it up. So atoms are making up everything, and we're going to look at the pieces that make up an atom. Then we're going to move on, and we're going to see how we can manipulate those pieces to make something called an isotope. So from your bin, you should have received this paper. Okay, it says Basic Atomic Structure. You're going to cut all the way around the black. Don't cut off the basic atomic structure. A lot of students do that. You want to cut all the way around the black. Okay? From there, what you're going to do is you are going to see, if you notice, there are dotted lines in the middle. You're going to cut up those dotted lines. You're going to cut across those dotted lines. Okay? The only one other thing you're going to do is at the top where it says electrons and where it says nucleus, you're going to cut that top black line as well so that you make 3 flaps on each side, and then the middle flap will flip up. So I did one for you. You can kind of see here, see how they're all, there's these different flaps. Okay, you can see where I cut the electron so it makes a flap. Okay, it's going to be very flimsy, but that's okay because you're going to glue along the back strip and on the data on the sides, and you're going to glue into the notebook page that I told you to in your assignment. Okay, and from there we're going to actually go ahead and move things around. So atomic structure, what is it? We're looking at the different pieces that are going to be building. You're going to need 3 colored pencils or 3 crayons, 1 orange, 1 green, and 1 blue. To help you color in your pieces. Okay, so get those now. So atomic structure, again, we're looking at our pieces that are making up our atom. So if our atoms are making up everything, what is making up our atom? So the atom. So it's the basic structure of all things. Okay, it's going to make up everything. Democritus, he's a Greek philosopher from our gallery walk. We learned a little bit about him. He said everything is made up of atoms, and then that jerk Aristotle came along and said, oh no, that's not true. And he said those things are made up of earth, wind, fire, and water. And we went almost 4,000 years with that knowledge. But you know, science finally came around, and we did discover the atom. And we've looked at the different pieces. So they're extremely small. John Dalton, he's a scientific teacher. See, teachers can discover things too. Okay, he comes up and he realizes that there is an atom. Okay, again, that's from your gallery walk. So he goes on and further publishes the theory of the atom. Okay, so we talk about how small is it? Well, it is extremely small. So you were taking a guess, you're probably thinking like top of a pinpoint, things like that. Okay, how many times would you rip this piece of paper up? So if I took this piece of paper right here and I ripped it up to display the size of an atom, we would be ripping for forever. Okay, the answer is 1.07 times 10 to the 23rd. That is a very big number. Okay, that's adding 23 zeros at the end of that number. Okay, such a big number. So what is an atom made of? Well, there's 3 subatomic particles we're going to look at. You have your proton, you have your neutron, okay? And both of those are found in the nucleus. And you have your electron. And your electrons are the ones that are spinning outside. So we're going to actually look at those right now. So proton, its symbol is P plus, excuse me. Okay, so underneath your proton flap, okay, so underneath your proton flap, you lift it up on your notebook paper, you're going to write this information. So symbol is a P plus. Why is it P plus? Well, because it has a positive charge. Okay, our atom structure has a positive and negative charge piece to it, and so our protons are going to be positive. Proton positive makes sense. It's inside the nucleus. It has a mass unit of 1 AMU, or atomic mass unit, so it has some heft to it. Okay. Inside with it is the neutron. Your neutron has a symbol of N0. It actually has no charge. It's neutral. You can think about neutron, neutral. Okay? And it's located inside the nucleus. And it also has a mass unit of 1 AMU. Finally, you have your electron. Okay, its symbol is an E negative, meaning, if you're playing along with the game, that the charge is negative. So we have a positive center, okay, because you have a positive and a neutral, and then you have a negative outside, okay? It's located outside the nucleus in the cloud, which we're going to talk about, and it has really no mass. It's such a tiny mass that we don't even count it. So our neutron and our proton are going to give us the heft of our atom, and our electron is going to give us what's called our volume. It's going to help us see how much space there is. So on your paper, after you've taken notes, anytime you see a P, I want you to color that orange. Anytime you see a neutron, or an N with a in a circle, you're going to color that green. And anytime you see an E in a circle, an electron, you're going to color that blue. Okay? So if you happen to notice on your paper, on your proton, neutron, and electron flaps, after you've written underneath them, you should have one of each of those, so color them accordingly. Again, orange for proton, green for neutron, and blue for electron. So next we're going to look at another piece, which is the nucleus. Like I said, the nucleus is positive because it has your protons in there. Okay, it's in the center of the cell. It's going to have our protons and our neutrons together. Okay, and its mass is the mass of the protons and the neutrons together. Okay, that's what is going to determine the mass of your atom. Every atom can have a different mass. Now, here's the thing. Your protons are going to determine what element you have. The protons and the neutrons are going to determine the mass of that unit, which will then in turn determine if it's an isotope of that atom. So, you can change the number of neutrons and still have the same element, but if you change the number of protons, your element's going to change. So if you have 2 protons, you will make helium. Okay? Now that helium could be helium-4 because you could have 2 protons and 2 neutrons. You could have helium-3 because you could have 2 protons and a neutron. Okay? However, if I change that number of protons to 3, my atom is now changed, and I have lithium because lithium has 3 protons. The number of protons is what's going to determine your element. Your electron cloud, well, that's negative, right? If the protons and the neutrons, okay, which have the positive and neutral charge are in the middle, okay, then the electrons, which are spinning on the outside, are going to make your electron cloud negative because that's where the negative charge is. It's going around the nucleus. It holds the electrons. And again, we looked before, electrons have no mass, so the electron cloud has no mass as well. And it determines the volume. How big is your atom? Okay. Finally, energy levels. There are 7 energy levels in our atoms. That's the number of rings that you have. How many rings are going to hold all of your electrons? And as we move away from the nucleus, our energy is going to increase because we can hold more electrons. Okay? And like I said, the energy level is where our electrons are held, so it's part of the cloud. Okay? So, we are going to look at that, we're going to look at the carbon atom, the carbon cutout that I gave you in your bin, and you're going to tell me how many protons, how many neutrons, and how many electrons there are. Your carbons should say carbon-12. Okay? So when we're looking at that sheet, okay, we're going to look and see what that looks like. But pretty much, again, the number of protons is going to tell us what our element is. Okay. The number of electrons is going to match our number of protons currently. We're going to talk about how that changes a little bit later. And then our number of neutrons is going to be determined by our mass number. Okay? So how can I identify an element based on its atomic structure? Well, like I said, every atomic structure represents an element. Okay? So you have to think about what element it is, and how do we know it, and what components help us to identify this element. Okay? The things that help us to identify it are our protons, our neutrons, and our electrons. So here's our carbon that we were looking at. Okay? So this carbon that we're looking at, if you notice, it looks very similar to the one you would see on your periodic table. However, this is a little different because there's some extra pieces here. So up here, I have its name, carbon. Not every periodic table will list the name of the element. However, it will always give you a symbol, okay, which is just a 1 or 2 letter representation. If it is 1 letter, it's capital. If it is 2 letters, it is a capital and a lowercase letter. Next, we have our atomic number, which is 6. Our atomic number is going to tell us the number of protons. And if we're looking at what's called a neutral atom, which means the number of protons will equal the number of electrons, our atomic number tells us the number of electrons. So in this case, carbon has 6 protons, and because we're going to assume that's neutral unless told otherwise, it's going to have 6 electrons. Okay? This number here, this 12.01, that's its average atomic mass. We're going to talk about average atomic mass in a little bit, but pretty much it takes all of the carbon isotopes and averages them out together. Okay? Most likely you're going to see this unless it's synthetically made in a lab or is a very rare find or only has 1 isotope on Earth. You're going to see it as a decimal because it is an average. Okay? And then this number down here, 11, you're like, well, if I already have my average atomic mass, why do I have another number? This number is your mass number. Your mass number is the number of protons and the number of neutrons for that specific atom, and that number can change. You can have carbon 11, you can have carbon 12, you can have carbon 14, because the number of neutrons is going to change, so it's going to change your mass. Okay, in the case of carbon 11, I'm going to have 6 protons because I have to have that number of from my the name of my element. Okay, and then I'm going to take 11 minus 6, and that's going to give me the number of neutrons. So I'd have 5 neutrons. So if you will go ahead and follow along, and you can see, you can label this in your notebook. So you're going to glue in your carbon, and you're going to label this as well. Sorry, I had to move my video a little bit so you could see. But these are the different pieces. Okay. All right. So label this on your on the periodic table element that I gave you. Okay. All right, and then tomorrow we will talk about isotopes and 8-man.